Going on to our last section in Math 105M, Section 6 of Chapter 9, dealing with solving exponential and logarithmic equations. And that's what we're going to be doing. So as we go on in this, I thought again we'd look at some of our PowerPoint slides to let us have a background in what we're doing. First off, what is an exponential equation? Well, it's an equation where the exponent is the variable. So as we see here and here, these are called exponential equations. Now actually in section, I don't know where they get the 12 from, but it's 9.3, we solved some of these. And basically the rule was if your bases are the same, then the exponents equal each other. So we'll be doing some like that. Let's take a look at this one, which is kind of an easy one, and you may recall it from a previous lesson. Here we have a 5 to the x power, and we want to see if this base can actually be some number in which 5 is the base. And if you recognize it, this is a perfect cube. It's 5 to the third power. So now that our bases are the same, we just say x equals 3. And that was the technique we used to solve it. Now, another method that we see here, if we have log base a of x is equal to log base a of y, then our x equals y. And we'll do one right here. So notice it's a little more complicated. Here our base is 3. Here our base is 43. Well, there's no way we're able to get a base 3 here because there's no perfect anything of 43. 43 is prime. So here we're going to use the log system. So if we put the log, and again we're going to the common log base 10, and we don't write the 10, we have something like this. Now that we have this, notice we can take our exponent from an earlier section, place it in front of the log. So we're removing our exponent to the front of log, which is one of our techniques. That was, you recall, the principle of logarithmic equality, the power rule for logs. Then what we do, and I don't like the way they write this, but we're going to divide both sides by the log base 10 of 3. And this is going underneath here. And again, this is underneath, and then we've transposed the positive one to the other side. And we have to put that in our calculator, of course, and this is what we get. Now, this, which is this, written in the way I like to write it, because it's showing you really what you're doing. Now, this is a log of log base 10, we don't write the 10, of 43, divided by log base 10 of 3, and then minus 1. Now, this is the exact answer. That's why they have equal signs. When we put it into our calculator and round off a little bit, here to 4 decimal places, this gets to be an approximate answer. But that is satisfactory. Going on to this example, here we have a natural log, e, that is to an exponent. Now, notice on this side then, we're going to convert this to natural log, e, and keep in mind that there is an e right there, because this is where we're going to use that what is this? This, you may recall from an earlier lesson, is 1. So that on this side, it just becomes this 1 point. We said when this is 1, our exponent, this is equal to this, and that's where we get the 1.32t is equal to the natural log of 2000. So this is what you put into your calculator, natural log of 2000, now divided by 1.32. And again, they didn't write it that way, I like, but there's your division sign. So now keep in mind that this is not a log here. This is a number. And we get an approximation of this. So as you do these, you really need to follow this model. And remembering there's a little e there, this side then became a 1, which is this, and this equals that, and you divide both sides by 1.32. And this is your approximation. This is exact. This is your approximation. Now, we also said earlier that you can solve logarithmic equations by converting them to an equivalent exponential equation. And that's what we'll show you here. So, let's take a look at this. So what is this saying? Well, this is saying our base 2 to this power is equal, this is our answer here, to that. So this is in its log form. This is in its exponential form. There's our base, there's our exponent, and there's our answer. So 2 to the 4th is 16. We're going to subtract 5 from both sides. We're going to divide both sides by 6. And we get x equals 11/6. And that's our answer. And we converted a logarithmic equation to an exponential equation. Now, when we see something like this, again, we're looking at a previous section where what does this refer to? Well, it refers to log. And again, these are all to base 10. These are common logs, which is going to be x times x plus 9 equals 1. So, and that is base 10. So we're going to say our base is 10, our exponent is 1, and that will equal our answer, which I'm going to multiply now, x squared plus 9x. So what I'm doing is converting this through a step of what we had earlier, keeping in mind this is base 10 here, common log, and then that is our base, this is our exponent, and this is our answer. Now this is a quadratic equation. How do we solve that? Well, we're going to move everything over to one side and have it equal 0. We're now going to factor, and this is a 10 and a 1. The 10 needs to be positive. This is negative. We then get our answers. X equals 1 or x equals a negative 10. Now we had said that we can't have logs, they're undefined, of a negative value. So we reject this one, and this is our answer. Now this is meant to be a mini lesson. I'm not showing you all the steps from the slideshow. Again, I have a video just on this, and this is what we've done, and that's what they get. Now, when we go to check the proof, we see that there's only one solution because the negative 10 does not work, and it is false. All right, let's take a look at this next example. Here we have a logarithmic equation, and we're going to convert it to its exponential form. So this becomes log base 3 now. And since this is a negative, we're going to divide. So this becomes 2x plus 3 divided by x minus 1. And we're saying that equals 2. So what is our base? Our base is 3. What is our exponent? It's 2. And then this is our answer. Now, what is 3 to the second power? We can just save a little room here by saying that is 9. And that's 9 over 1. And we can cross multiply now. We get 9x minus 9 equals 2x plus 3. Just cross multiplying. Well, this gives me 7x as I subtract 2x from both sides, or transpose. This becomes a positive 12 on the other side when we add the positive 9 and 3, and we get x equals 12 sevenths. And that's our answer. If we look the way the book is setting this up, the slide, I don't like it. I like the division. The way I showed you, you get the same answer, and there is your answer. They don't even write the answer the way I like. Okay, getting back to our textbook material, or our mini lecture. Here are examples, not too many, but they're going to feature what we've talked about. So here we have equations in an exponential form. So let's solve them. And again, you want to take notes on this. We'll do it down here. 1a. And it's 3x to the 5th equals 27. Now, when we see a number that is a perfect cube, this is kind of easy to solve because you go 3 and then the exponent 5x equals 3 over here to the third. So now your bases are the same, and that just becomes 5x equals 3, or x equals 3/5. So that's the answer to letter A. And now for B, we'll keep some of that up. We have 9x plus 1 equals 43. Now, as you look at the 43, is there any possibilities of having some number with a base of 9 like we did here? And the answer is no. So what you have to do here is convert this to a log. And I'll just put it right in there. So now that this is the log, I've converted an exponential equation into a logarithmic equation. I now can take my exponent, which is x plus 1, put it, and I'm going to put parentheses here, in front of log, and remember that's log base 10, we just don't write it, equals log of 43. Now, what do you do? Well, we can actually divide now both sides by the log base 10 of 9. These will cancel out on this side, and I'm left now with x plus 1 equals this over here. And what does this become? Well, I'll write it. It will be log 43 divided by log 9. Now this positive 1 goes on this side as a negative 1. And then we get x equals this. Now, this is the exact answer. You're going to put this into your calculator, log 43, divided by, you hit the divided by key, and you just put log 9, enter, get an answer, then subtract 1 from it, and you get 0.712. Now, when you did this, you got a 1.712, but then you subtracted a 1 from it and got this. And keep in mind, this is the approximate answer. This one was the exact answer. And the technique we used, since this didn't go into a nice power of 3 that we needed to get our bases to be alike, we just switched it over to logs. And then using our calculator, we're able to get this answer. Now, as we do letter C here, let me write it. We're going to convert this, since it's natural log, to natural log base E, and then this is our E that's there, and this is our exponent. And we're going to convert that to its natural log also. So what happens now? Well, do you remember from an earlier lesson that this arrangement here is just 1? So this side just becomes the exponent. So how do we find out what t is? Well, we just divide both sides by 0.11. Now here you have to be very careful, because when you put this into your calculator, it's going to be the natural log 775 divided by not any logarithmic value, but just the plain 0.11, and that will give you 60.481. Now remember, this is approximate. This is the exact answer. Now as we look at letter D, we haven't had instruction on this because you can't use our common log system to solve where we have a variable in the problem and also in the exponent. Now, if you could plug this into your calculator, you do get an answer. So this is something we are going to skip, since we're not requiring you to use a calculator. Okay, let's go on to 2. I can remember when I first looked at this and I said, wow, how do we do these? Well, I had to read the textbook again to refresh my mind. And then, I've worked through the textbook pages and the PowerPoint and the additional exercises. And I also, by the way, sat down and did these before I attempted to give a lecture on them. So I know what's going on here, but it looks daunting as you first look at it. But here, it wants you to convert from logs into exponential equations. So let's look at letter A here. Well, our base is 5. Our exponent is 2. And our answer is this. And you might say, wow, that we know that technique makes it so much easier. So this is going to be 25 equals 7x minus 3. Going to transpose the negative 3 over, becomes a positive 3. And we divide both sides by 7, and we get x equals 4. Now, if you put a 4 there, this is 28. 28 minus 3 is 25. So if you look at that, it's log base 5 of 25 equals 2. And what does this mean? Well, base 5 to the second power equals 25. Yes, and we solved it in logarithmic form by converting it to exponential form. All right, we're going to do the same thing for letter B. Now remember, our base here, this is a natural log. So it's natural log base E 3x equals 7. So our base is E, our exponent is 7, and it equals 3x. We have converted this from its sort of logarithmic form to its exponential form, and now we just solve for x. Divide both sides by 3. This would be our exact answer. And then if we put e in our calculator and raise it to the 7th power, and then divide it by 3, we get an approximate answer of 365.544. It's almost the number of days in a year. Isn't that interesting? Okay, now let's do number or letter C here. So as we look at it, it's in logarithmic form. So let's put it in its regular form. Here we have log base 7 of x times this, and that equals 1. So we have then, we're going to convert it to its exponential form. There's our base, there's our exponent, and it equals this. So I'm going to take this now, bring it to this side as a negative 7, and convert this now to a quadratic equation. How do we solve quadratic equations? Well, we factor them. This is a plus, this is a minus. So we get x equals 1 or x equals negative 7. But as we just said a few moments ago, can we have a negative 7 as a logarithm? And the answer is no. So we reject this one. Our answer is 1. And the technique we used was to convert it from a logarithmic form into its exponential form. You master this, of course, by taking good notes, using these notes as a model, and then practice in your quiz me, then your test. So we're going to go here log base 3, and it's subtraction, so we need to do division here. And it equals 2. Now, we are going to go our base, which is 3, to the exponent 2 equals x minus 4 divided by x plus 5. And 3 to the second, we know, is 9. That's 9 over 1. So what technique do we use? Well, we cross multiply. Here we get 9x plus 45 equals, cross multiplying, x minus 4, which gives us then, subtract x from both sides, 8x. subtract 45 from both sides, and this gives us a negative 49, and divide both sides by 8, we get x equals a negative 49/8. And if you look below, that's your answer. Again, it looks daunting, but through your practice of what you've done before, you know the technique, and just grind it out. And here we went along very well, but now this one's done a little differently. This is not just like a regular number here. This is a log, but you do it in a similar way using your algebraic skills. Log base 13 is equal to, or base 13 of x minus 4, x plus 4. If you recall, these are conjugates. This is going to equal the log base 13 of 9. And since this is an equation, what we can do here is divide out log base 13 on both sides. So these now cancel out. We FOIL this and get the difference of perfect squares. We then transpose this and get x squared minus 25 and factor that. And this becomes x equals negative 5, x equals 5. Now notice your negative 5 would make this a negative value here, which is undefined. So we eliminate that, and this is our answer. Well, hopefully you are doing your practice, your quiz me's, your test, and you're going to be ready shortly for your exit exam. Good luck to everybody, and wish you the best.